This is the lab lecture video for the procedure portion of the Gen Chem 2 lab, Colligative Properties, Freezing Point Depression. Again, there's going to be another video for calculations and background content for this lab. So this one is just focusing on using the glassware, chemicals, equipment appropriately. So for this lab, you're going to need to wear gloves, but we will be using the nitrile gloves, not the latex gloves. Again, the nitrile gloves are typically blue, sometimes they're black, but the latex gloves are the white ones. So for this lab, the first thing we need to do is make a salt water ice bath. Okay, now the lab tells you to do this in part A at the beginning, which we have to do. But it also recommends that later in the lab that you remake this or adjust it in some way. This saltwater ice bath, its job is to be really cold so we can freeze stuff that's submerged in it. Well, as ice sits out at room temperature, it's going to, melt and it's going to get warmer. So if you ever feel that your saltwater ice bath is getting not as cold, not as icy as it once was, then dump it out, remake it. You're going to be using sodium chloride as the salt, so same thing as table salt, ice and water, so nothing is harmful, and this ice bath can go down the drain when you're finished. So to measure out the sodium chloride, you need to get 50 grams of this sodium chloride, which is not a thing. We don't need to get an exactly 50.0000 grams, but I don't really expect that you can just eyeball 50 grams. So you're going to want to use the analytical balance for this. So instead of using weigh paper, which is what we use when we're measuring out small amounts of a chemical, you're going to be using a weigh boat for this. It's a little bit sturdier. It can hold large amounts of chemicals. So you're going to put the weigh boat on the balance, close the doors, tear it, and then using your scoopula, transfer sodium chloride into the weigh boat until it's about 50 grams. You do not have to record this value anywhere. And then you're going to transfer it into a 600 milliliter beaker. You're welcome to rinse it to get as much off as you can. Then you're going to slowly add about 10 milliliters of water. Now, most of the time in the lab, and by most I mean almost every time, if it mentions water, we mean deionized water, the nice clean water. You can use deionized water here, but you can also use tap water because this is just a saltwater bath and we're already not contaminating it, but we're adding sodium chloride to it on purpose to make it freeze at a colder temperature. So you're adding about 10 milliliters of water. This does not have to be accurately measured. And then you're going to stir this using a glass stir rod that is here until some of it has dissolved. Now, it's not possible for you to get 50 grams of salt dissolved in 10 milliliters of water. So stir until some of it's dissolved, but you know there's going to be some solid left. At that point, you're going to take the ice that's going to be provided for you. It's crushed ice. And you're just going to add it to your beaker until the total beaker is about 2/3 of the way full. You don't have to measure the amount of ice. You're just going to transfer it in. Once it's in there, I want you to stir it up really good again. What's going to happen is some of that ice is going to melt to become water because it's cold, but it's at room temperature now. So you can continue to add ice if you need to, but we will be submerging things into this, so don't fill it up so much that it's going to overflow if we drop something into it. Okay. So as the ice slowly melts and becomes water, some more of that salt is going to dissolve. We want to keep this saturated at all times, meaning there's always more salt at the bottom that's not completely dissolved. And at any point, you're welcome to just stir it up a little bit as we continue with the experiment. Okay, so for part B, what we're wanting to do is to freeze pure cyclohexane. Okay, so we're going to be submerging it into our ice bath. But our cyclohexane and all of the chemicals we're working with are going to be inside of test tubes for this lab. So it's going to be nested test tubes. We have a smaller test tube. It's going to be placed inside of the bigger test tube. The smaller test tube is where the chemicals will be transferred to. The bigger test tube's job is to prevent supercooling, so to kind of let things as they cool and freeze, to do so evenly, so it's not like a little bit, part of the liquid gets super cold and freezes, but the rest of it's still nice and warm. We want it to be nice and consistent. So whenever we're adding chemicals to these, I would suggest separating the test tubes. So the big one is just hanging out, and the small one is where we're going to be putting the chemicals. The issue with having them together while you do this is if you spill a little bit, some of the chemical gets stuck kind of right where the two test tubes are together, so it's better just to separate them. So cyclohexane is the chemical that we're freezing, and it is a liquid. So we're going to transfer the cyclohexane into our smaller test tube using a volumetric pipette. So you're going to transfer 10 milliliters of the liquid. So we'll be using a 10 milliliter volumetric pipette. So please watch the video on how to use a volumetric pipette. Before you do this, you will have to condition it with the cyclohexane, pouring cyclohexane into a beaker, and then pipetting it out of that beaker and transferring it into a waste beaker. That's when we condition it. We're rinsing out the insides. Once you've conditioned it, you're ready to use it. So you'll use your bulb and get the level of liquid above the line. Use your finger to slowly release the liquid until it's right on that line. And once you've got exactly at the line on the pipette, I said to separate the pipettes or the test tubes, and then I didn't do it. You're going to be transferring liquid into the test tube. So that's where we want the liquid to end up. Remember, when you're pipetting, let gravity do its job, let the liquid drain. There's going to be a little bit of liquid left in the tip of the pipette. That's fine. Leave it there. It's supposed to be there. You will only use this pipette once. So when you're finished with it, you're not responsible for washing it. It needs to be put in the appropriately labeled container. So you're welcome to, put it in a nice, safe place to the side, or go ahead and put it in that container at that point. Now, cyclohexane cannot go down the drain, so make sure when you condition it, you put it into a waste beaker, not in the sink. Okay. Once our liquid is in our smaller test tube, now it's time to join it back with its bigger test tube friend. Okay, so we're wanting to freeze this, but even more, we want to record the temperature of this happening. So we need to get a thermometer involved. Now, the big test tube, we have a stopper that fits perfectly in the top of that. Okay, now that stopper that we're going to use has 2 holes in it. One hole is where we're going to place the thermometer, and the other hole is where we're going to place a piece of copper wire that we're using as a stirrer. Now, the 2 holes, one of them will have, been cut. So I'm stretching the stopper. I don't know where to put it so we can see it. My fingers are too big. So one side will have a cut through it, so that way that hole can be opened up, and the other one does not. So the thermometer is going to go through the cut hole, because thermometers are much wider than the copper wire. So at this point, usually because the hole is cut, as long as you rotate it, you're going to be pretty safe putting that putting the thermometer through the stopper. If you feel like there's a lot of resistance and it makes you nervous, we also will have glycerin, which is a lubricant that you can use to help make this a smoother transition. So in the safety video, there was a whole thing about putting glassware into a stopper, and then the glassware broke and shoved into somebody's hand, and then they bled everywhere. So we don't want that to happen. Okay. Now your piece of copper wire is just going to be a piece of copper wire, but the bottom will be kind of curled around. It's to stir, but to fit around the thermometer. So the top of the copper wire will just be straight. That goes through the other hole. It fits nice perfectly through there. And then the rounded part of the copper wire goes around the thermometer. So it has like a little bracelet. What that lets us do is we can use the copper wire to mix the solution around the thermometer so it's not banging into it. Once we've got that prepared, we want to add this to our test tube, which has our cyclohexane. Now at this point, you want to double check the location of the thermometer. You want the tip of the thermometer to be submerged in the liquid, but you don't want it to be touching the bottom or the sides of the test tube. So if you need to adjust the thermometer's height, you can do so at this point. So now it's all set up. We're ready to freeze stuff. But what we need to do is submerge this into our salt water ice bath that we just made. Okay. Well, to do that and to do it carefully, we're going to be using a clamp to hold this. So we have 2 options on what kind of clamp to use. So we've got our post here that I've already put in the counter. If you're in a fume hood, you'll use one of the posts that's already in the fume hood ready there. We've got what's called the test tube clamp. It's got a side that attaches to the post. Thought I had it prepared. I was wrong. There we go. Okay, so I attached it and then I tightened it. And then I'm adding my test tube, the test tube clamp, and then I'm going to tighten it until it can support the glass test tube and all the other stuff. And then I'm going to lower it so that way the cyclohexane mixture is inside of my beaker. So we want to make sure that the liquid in the test tube is below the ice bath. So if you need to lower it or raise it, that's fine, but we want all the liquid to be covered in the ice. At this point, we're sitting here and waiting for it to freeze. So when cyclohexane freezes, it's going to look like ice, like it's going to turn solid. You can also tell, it's going to be hard to see because it's going to be surrounded in like the saltwater ice bath. But when your copper wire no longer moves, I would say that's a good time to check it out. Now, depending on how well you make your saltwater ice bath, it might be that this freezes pretty quickly if you made it really well, or it could be that yours takes longer. I would suggest checking on yours because once it's frozen, you don't want to let it to continue to get colder and colder and colder. It's just going to take the experiment longer for you to complete. So once it's frozen, like frozen solid, okay, like all of it is frozen, we're ready to move on to the next step. And that next step is to start making temperature measurements to watch the cyclohexane melt. So the freezing point and the melting point are the same thing. So we're going to make measurements while it melts after it's already been frozen. So once it's completely frozen, you'll have a stopwatch that you've been given. You will raise the liquid or the test tube out of the ice bath. Start your stopwatch. And then you're going to record the temperature every 30 seconds until the temperature gets to 12 degrees Celsius. So you're going to start with, on page 18, our data table, there are two for trial one. There's a temperature column and a time column. The time column is in minutes. So if I want you to make a measurement every 30 seconds, think about how many minutes that is. So don't write 30 in there because then that's telling me 30 minutes. Okay. So you're going to start with a time 0, which is what the temperature was when you first pulled it out. You'll record the temperature, write it down, write down the time. Now, it doesn't have to be exactly perfect. So if, at 2 minutes, it was 2 minutes and 10 seconds. I don't care, write down 2 minutes. It's fine for this. I don't know exactly how long yours is going to take to get to 12 degrees Celsius. It completely depends on what temperature you started with. So you're just going to keep recording this until you get to 12 degrees Celsius. So at that point, and someone needs to be stirring the whole time. So you're going to need to be stirring it. I mean, you can take breaks, but like stir it, and then when it's time to read it, and then write it down, and then stir it a little bit until you get to 12 degrees. Once it's at 12 degrees, you're finished with that trial. Now we're going to repeat the whole thing, which means you're just going to lower this back down into the ice bath until it freezes. And then once it's frozen solid, you will once again raise it up. Ooh, so strong. And start the stopwatch and make temperature measurements every 30 seconds until it gets to 12 degrees Celsius. The good news is the second time, it freezes a lot faster because it's only at 12 degrees Celsius when you lowered it back in there. And we started at room temperature, which is about 25 degrees Celsius. So that takes us through part B, okay? Yeah, okay. So for part C, do not move on to part C until you've completely finished with part B because there's no going back. So make sure you did both trials in part B before you move on to part C. What we're doing in part C is we're going to add an unknown solute to the cyclohexane. So the cyclohexane that's in your test tube, we're going to take it off out of the clamp. We're going to remove the stopper, the thermometer, and the copper wire. And, well, I guess before we do that, you're going to measure out the unknown number solid that you were given. So the unknowns are going to be just white solids in little vials. And using a piece of whey paper for this, because we're only measuring a very small amount, you're going to be measuring out about 0.3 grams of your unknown solid into your whey paper, recording that value very accurately. I suggest staying as close to 0.3 grams as possible. The more unknown you add, that's more solid you're going to have to get dissolved, and it's going to take a while to dissolve it. So I would suggest as close to like 0.30 something something as possible if you can do it. But it does need to be at least 0.3 grams. That's kind of the minimum we need for the experiment to work well, but you don't want too much more because it's just going to make your experiment take longer. So you'll accurately measure out your 0.3 something 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 grams from the balance. Now is when we're going to remove everything, and you're going to want to set this on a paper towel. We don't want to contaminate this by setting it on the counter. So stick it on a paper towel, and then I'm going to very carefully remove the inside test tube from the outside test tube. Remember, the inside test tube is where the cyclohexane is. Once you've measured out your solid, you then need to very carefully transfer the solid on the whey paper into the test tube. I like to make a little taco with mine and do that. Some people like to fold their whey papers before they measure the mass to make it a little easier to control. I don't care what method you use, but you need to get the solid transferred into the test tube and do the best you can to get all of the solid into it. We cannot rinse this because we can't add anything to this. We want this to be a mixture of pure cyclohexane that's exactly 10.00 milliliters of pure cyclohexane, and however many grams of unknown. So just do your best to kind of tap it to get the solid. Once the solid's transferred, that can go in the trash can, and then we're going to put this whole thing back together again. And so when we do that, once it's together, now your job is to use the copper wire to stir this until the solid completely dissolves. Now, this liquid's still going to be cold because you just got finished freezing it for the second time. So we know that solubility is temperature dependent. So first I would just try to use your copper wire to mix it up, to try to stir, to dissolve it as best you can. If it's taking a really long time and it's not dissolving very well, use your hands to kind of cradle your test tube and warm it up a little bit. Okay, so the good news is that's going to make the solid dissolve faster and easier. The bad news is after we're done with this, we're going to turn around and freeze it again. The warmer you get it now, the longer it's going to take to freeze it the next time. Okay, so you kind of have to use your judgment on that. Hopefully it dissolves really well by itself. Now, this is a time when I probably suggest trading out your ice bath because at this point it's been sitting a while. You could completely start all the way over, or just pour out some of the water from the top, add a little bit more salt, add some more ice. You could have constantly been doing that between the trials. I don't care, but I would make sure that your ice bath is nice and fresh because in part C, this mixture needs to get even colder than our pure solution did in part B. So our ice bath needs to be ready to go. Okay, so once it's dissolved, put everything back together. And then you're going to dip this down and let it freeze. Now, the mixture, when it freezes, it doesn't usually freeze quite as solid. It doesn't look exactly like ice, like the cyclohexane does. But it gets super clumpy and slushy to where when you move the copper wire, it kind of just, it moves. So think like a really thick, like slushy kind of thing. You need to be able to feel the resistance when you use the copper wire. Okay. Once we've reached that stage, we're going to remove this from the ice water bath, start our stopwatch, record the temperature every 30 seconds until it gets to 12 degrees for trial 1. And after trial 1, you'll submerge it, freeze it a second time. Once it's completely frozen, raise it up, start your stopwatch, taking the temperature every 30 seconds until it reaches 12 degrees Celsius. So you're doing this a total of 4 times, twice with the pure cyclohexane and twice once you've added the unknown to it. So that's why you have to make sure you're completely done with part B before you move to part C, because you just added something. You can't go backwards to it being pure anymore. Now, at the end of the lab, when we clean up, which once we've done our 4 trials, we're ready to do that. The salt ice water bath just goes down the drain. It's just salt water, ice, and water. The waste beaker, whatever waste you have left, plus any excess cyclohexane, if maybe you poured some into a beaker and you got too much, that plus the liquid inside of the test tube, all of that needs to go in the same waste container. It'll be the non-halogenated waste container. So all of our liquids go into that waste container. Once you've poured the chemicals into the waste container, you need to use acetone to rinse the glassware. Acetone is in the red bottles, or red. Oh. I'm coming back. Should have hit pause. Too late. Okay. In the bottles with the red lids, so deionized water has blue lids. Right? Acetone has red, sometimes yellow lids. So you're going to rinse all your glassware. So the inside test tube, you have to rinse that. Your cyclohexane beaker, your waste beaker. All those need to be rinsed with acetone, and then the acetone rinse also goes in the waste container. Once you've rinsed with acetone, you can wash the glassware and put it away like normal. So the test tubes, the copper stirrer, and the stopper are all going to be placed in a designated container. The thermometer came from your drawer though, so you need to wash it and make sure it goes back. The beakers need to be washed and put back, and you just have to put away the clamps. So again, watch the other video for information on calculations and the background content of this lab.